So this video lesson is all about the distributive property. And in order to talk about the distributive property, first I want to look at a swimming pool. Actually, not really that swimming pool. Let's look at this swimming pool instead. Now, one of the things that is talked about when we look at swimming pools is how many people can we fit in it, how much space does the swimming pool have. Basically, what is the total area of a swimming pool? And now this kind of shape is a difficult thing to find an area of because it has a lot of different things that go along with it. But if we were trying to find out what the area was, one of the ways we could do that is by splitting it up into two parts. We have the smaller square part in the upper right hand corner of the pool, which looks like the shallow end, and the larger rectangular area down at the bottom, which you can see those black lines at the bottom of the pool that indicates there's some competitive lanes, so people are swimming laps and is a slightly deeper end. And so when we're finding the area of a pool, what we can do is we can split it into smaller parts. Even a pool like the one we looked at first, as a rectangle, we could split it into smaller parts. And then we can find the area of one and add it to the area of another. And in one way, that's part of how we use the distributive property when we're talking about numbers, is to take a large sum or a large difference and split it into parts. What we are going to talk about is not using the distributive property with numbers, which we haven't even gotten to what the distributive property is yet. We are going to look at it from a slightly larger sense in terms of math. So let's take a look at this scenario. Let's say that you have a Reese's peanut butter cup, maybe you have a half-eaten Reese's peanut butter cup if you've eaten the other half, but let's say you have a whole one, and then 2 Honeycrisp apples. Now, if we wanted to, you could just eat these and be done with it, or maybe you have 2 friends who are coming over and you would also want them to have the same kind of food that you have. So we would want a total of 3 of this, which we can represent as a peanut butter cup plus 2 apples. Well, if we have 3 of this complete set of things here, then each person would need to have a Reese's peanut butter cup. So we would need 3 peanut butter cups, but we would also need each person to have 2 apples. So if we created 3 sets of a peanut butter cup plus 2 Honeycrisp apples, we end up not just with 3 peanut butter cups, but we end up with 3 groups of 2 Honeycrisp apples, which in total is 3 peanut butter cups and 6 Honeycrisp apples. So when we've multiplied this by 3, we've actually created 3 copies of everything that's inside those parentheses. Let's take a look at a different thing here. Maybe instead of creating 3 sets, you actually wanted to create 4 sets of this peanut butter cup and 2 Honeycrisp apples. Well, we can use the same strategy and say, if we have this, if this is what we have in a bag or on a plate or something like that, and we want 4 equal copies of it, well, that peanut butter cup needs to be multiplied by 4 in total. And so do the apples. And so what we've got seems to be the idea that if we're creating multiple copies of something that contains a lot of elements, we need to be able to multiply all of the different elements together. Let's see if that still holds, or multiply each of the different elements and then add those all together. Let's see that in a slightly different scenario with more peanut butter cups and more apples. Let's say we have 2 peanut butter cups and 3 apples. And we want to make sure that we have 4 copies of this complete thing here. So we have a plate with 2 peanut butter cups and 3 apples on it. We want to have 4 plates that look exactly the same. Well, each plate then is going to require 2 peanut butter cups, so you need that 4 times. And it's also going to contain 3 apples. So you need the apples 4 times also. Not just the peanut butter cups or just the apples, but the peanut butter cups and the apples. And that's what the distributive property says. It says that if we are multiplying some or a difference inside parentheses by a number, that we're not multiplying just the first part of it or just the second part of it. We're multiplying everything. So to take this b plus c in the middle of those parentheses and multiply it a times, that means we need that many b's and that many c's. So go ahead and pause the video. You're going to write down the distributive property. And then you're going to write down these two variable forms here. Now remember, variables just represent numbers. They're any numbers we want. We can put positive numbers, negative numbers, fractions, decimals, anything we want in here, and this still holds true. Once you're done writing this down, we're going to take a look at a few more examples. But for right now, go ahead, pause the video, write this down, and we'll move on when you are ready. So let's take a look at what that means when we have a number specifically, where we just have numbers. Let's say we have 5 times the quantity of 2 plus 3. Now the order of operations would tell us that we should add the 2 and the 3 first to get 5 times 5 and end up with 25. And that would be a totally correct use of the order of operations. But here we want to use the distributive property instead. So the distributive property tells us that if we have something in parentheses, a sum or a difference, or really anything in the parentheses, and we are multiplying it, the whole thing, that whole set, by 5, we're going to multiply not just the first number by 5, but the second number by 5 also. So 5 times 2 plus 5 times 3. And it's important that this operation here just comes along with it. So it's not just 5 times 2 plus 3, it's 5 2's and 5 3's. And if this property works, we expect that this sum is 25. And it turns out, when we add 10 plus 15, we do indeed end up with what we want, which is 25. Now when we just have numbers, it seems a little bit silly to use the distributive property because we can just calculate what's going on inside the parentheses. And in following with our use of variables and more complicated things, let's take a look at what this means if we have a variable expression. So this is 2 times a quantity x plus 4. Now what that means is we have this x plus 4 in parentheses, and we're multiplying that whole thing by 2. So really what we have is 2 copies of x plus 4. Not 2 copies of the x only, or 2 copies of the 4 only, but 2 copies of everything. So in total, we have 2 x's and 2 4's, which is 8, which is exactly what we get if we multiply the 2 times x and the 2 times 4, and then keep that plus sign in the middle. So we can distribute that to make it 2x plus 8. And the whole goal here is to change the variable expression in some way so it's a little bit easier to work with. 2x plus 8 is a whole lot easier to work with than 2 times x plus 4. If you'd like to, go ahead and pause the video here and see what you can do. Remember, the numbers can be positive, negative, fractions, decimals, anything. So if we have a negative number on the outside, we're just going to take that and multiply that through everything. We can't drop the negative there. So if you'd like to pause the video, go ahead and do that now. Work on this. If not, you can let it keep running, and we'll go over how to work with this through the distributive property as well. So like we said, that first number gets multiplied by everything because we have negative 2 copies, whatever that means, of x plus 5. So negative 2x's just gives us negative 2x. Negative 2 5's gives us negative 2 times 5, or negative 10. And then we keep this plus sign here. So that is negative 2x plus 10. Now we can also write that as negative 2x, or negative 2x plus negative 10, rather. We can also write that as negative 2x minus 10. That is okay. As well as is negative 2x plus negative 10 for the moment. Right now we're just working on being comfortable with using the distributive property with variables. And so now we've got 4 problems for you to work on. Go ahead, pause the video, see what you can do with these 2 problems, and come back when you're ready to find the answers and move on. So for the distributive property, our first number, our outside number, the first factor there, gets multiplied by everything in the parentheses. So 3 x's gives you 3x. 3 7's gives you 21, or 3 times 7. And then we just maintain the subtraction sign, and it's 3x minus 21. Here we have negative 4 times g. Remember, we have to take everything and make it negative 4g. We have negative 4 times 9, which is negative 36, which we got from negative 4 times a positive 9. And now we're just going to take this plus sign and bring it down and make it negative 4g plus negative 36, or negative 4g minus 36. Both of them are acceptable answers at this point while we're starting to work with the distributive property. Let's go ahead to these two problems here, see what you can do, pause the video, work through them, and come back when you are ready to move on. So we've got, in the first one, 5 times the quantity of x plus y. That means there are 5 x's, which is 5x. There are 5 y's, which is 5y. And we maintain that addition sign, so it's 5x plus 5y. And for the one on the right, we have negative 8 times x, negative 8 times 4, which is negative 32. And we keep the subtraction sign. Now we could stop here and call this negative 8x minus negative 32, but if you're anything like me, you're a little bit bothered by the fact that we have 2 negative signs, or a subtraction sign followed by a negative sign, or 2 signs that look that similar right next to each other. And so we're going to use something that we've done with subtraction to be able to change that, to put it into a slightly nicer form, where when we changed subtraction problems, with our shortcut KCC to help us remember what that process is and how that process works, we were able to take this and we would have made this negative 8x to start off with, because that is the first term. We're going to keep that. That subtraction is going to become an addition, and then that negative sign is going to become positive, so we make it negative 8x plus 32. And this is the one time that I'm going to be insistent that we actually change the negative signs and the positive signs. We can leave it in terms of plus a negative, that's fine. Sometimes it's left like that anyway. Or we can change it to subtraction, like we showed here. But when we have negative 8x minus negative 32, if we're subtracting a negative, we're going to want to change that to adding a positive. In part because it gives us a better idea of what's going on, and also because it's a little bit cleaner and easier to look at. So in total, why did we use the distributive property? Well, in one sense, we were using the distributive property so that we could make sums easier when we have numbers, but really when it comes to variable expressions, it's to be able to change them into some more helpful and easier to work with form.